First of all, we start off with a new definition of a normal. Now, you probably, for those of you that have taken physics, you've heard of normal forces. In mathematics, it's very similar. If we have a point, on that point, this green line would be the tangent. And this purple line at 90 degrees, that would be the normal. So our derivative, remember, what does a derivative do? It tells us about slopes of tangent lines. So our derivative will figure out the slope of a tangent line, and if we want to find anything about a normal, then we just have to find the slope of the tangent. First, 90-degree perpendicular. Do you remember that the slope of a perpendicular is the negative reciprocal? In other words, the fraction flips and it becomes negative. Yes? No? So if this green line had a slope of -3/2, then the purple line, being at 90 degrees, would have a slope of +2/3. That's from grade 10 pre-calculus, where the slope of perpendicular line is you flip it, and it becomes the opposite side. And what will always happen is when you multiply these two together, you will always get -1. So now we can have similar questions to the ones we just did in the last class. We actually did notes. It can say, can you find the equation of the normal line? Right? And again, we say to ourselves, find an equation of a line. You need two things. One, you need the slope, and two, you need a point. We've already got the point. They tell us at 2, -5. All we need now is the slope. And this is where calculus comes in. If calculus finds us the slope of the tangent, then we can use the slope of the tangent to find the slope of the normal. So finding our derivative, in this case, really easy. 3 comes out in front. Subtract 1 from the exponent. 2 comes out in front. Subtract 1 from the exponent. The derivative of -5 is 0. And at x equals 2, the slope of the tangent is, well, we just plug in 2. And you see that you would have -24 plus 16, -8. To find the equation of the normal, we would get 1/8. So sometimes in this, you'll see some people add like a little t there to say slope of tangent and a little n there, just to differentiate. One of them is the slope of my tangent, one of them is the slope of my normal. You can do something like that just to help clarify things. But does it make sense that now we have the slope and the point, and you can choose either y minus y1 equals mx minus x1, or y equals mx plus b to find your equation. Which one are you more comfortable with? Should I do them both so you see them both? Yeah? Okay. I'm guessing more people are more comfortable with remembering y equals mx plus b. So you would plug in your slope of 1/8, your point, which when x is 2, y is -5, and that would allow you to solve for b. You get -5, this is 1/4 minus 1/4 equals b, get a common denominator, and you get -21/4 equals b. So our final equation will be y equals 1/8x minus 21/4. minus y1 equals m x minus x1. You'd plug in your point. Again, y value is -5. The x slope was 1/8. The x value was 2. We'll give you y plus 5 equals 1/8 x minus 1/4. Subtract 5 on both sides. 5 is 20/4. So you would get the same equation whether you used one form or the other. So find the equation of a normal line at the point 1, 4. So as far as things that we need, we have the point. We need the slope. To find the slope of the normal, I'll first find the slope of the tangent. I find the slope of the tangent with my derivative, but before I get to my derivative, you see that we have to do a little bit of rearranging in this equation, because it's not in the normal form that we can find the derivative. Are you okay if I do this in one step? Because the square root is x to the half, but the first square root is in your denominator. So to bring it to the top, you'd have to use your negative exponent rule. So there you would get x to the negative half. Then once it's in this form, you can find your derivative. Negative comes out in front, negative half comes out in front. Subtract 1 from the exponent. Half comes out in front, subtract 1 from the exponent. At x equals 1. Okay? Now, you might have to, for yourself here, to evaluate this, you might have to change this back to square roots. Because once you change it back to square root, then it's a little bit easier to plug in 1. Because here I'm going to get 1 cubed, which is 1, and then square root it, which will still be 1. So I will get -5/2 minus 1/2, which is -6/2, which equals to -3. And this is the slope of my tangent. If that's the slope of my tangent, I can now say the slope of my normal. Flip the fraction, change the sign, negative reciprocal, 1/3. Plug in your point, plug in your slope, find your b value. This will be 12/3 minus 1/3, 11/3 would equal b. The IB course likes to ask lots of graphing calculator questions. Here's an example of a graphing calculator question. It says, find the equation of the tangent at the point -1, 2 on this curve. So again, you want to find the equation of the tangent. You're going to need the slope of the tangent. You're going to need a point. We're given the point, -1, 2. We would find the slope with derivative. And then plug in -1, sorry, and you would get y prime equals 3 minus 5 equals -2. So the slope of the tangent is equal to -2. And once we have the slope of the tangent and the point, y equals mx plus b, we know our slope is -2, our x value is -1, our y value is 2. We can solve for b. And we can write our equation then, that our equation is just -2x for our tangent. So if I draw a picture of this on my graphing calculator, I'm going to go to y equals. I'm going to type in x cubed minus 5x minus 2 into y1. I'm going to type in my equation of my tangent, which was -2x, in equation 2. And hit the graph button. Can you see? Here, I'll drag it over here. Maybe. Maybe not. Try that again. Oh, I did. Can you see that we have the -1, 2 point right there? Can you see that that red line looks like the tangent at that point? Can you see that it intersects the graph again here at the purple point? So we drew our graph, we drew our tangent. This question is saying, use your graphing calculator to find the point where this tangent meets the curve again. Okay? So I go to my graphing calculator. I want to find out where these two graphs intersect. Your graphing calculator will always find the one that is nearest to. So if you use your cursor to get closer to this one and push enter once, enter twice, enter third time, it will find that second one at 2, -4. So we can now say, we can answer the question, where does this meet the curve again? It meets the curve again at 2, -4. How would you do this without a graphing calculator? If you're wanting to find out where two graphs intersect, can you see, this was that's the equation of our red graph, and the equation of our blue graph was right here. What are we doing when we find two graphs that intersect? We're solving that system of equations. Would this one be hard to do without a calculator? Maybe a little bit, because what would you have to do? You would have to plug in -2x for y, and then you would have to attempt to solve this equation. How do you solve the cubic equation? You make one side equal to 0. And you have to factor. How good are you at factoring? Cubics, do you remember the remainder theorem, synthetic division, all of that? That's what you would have to do in this case. Oh, sounds like fun. You actually know, though, that one of the solutions is, because it touches where? It touches at -1. So you already know that one of your solutions is going to be -1. That means when you factor this, that x plus 1 is a factor. So if you did your synthetic division, you'd have a -1 out here, 1, 0, -3, -2. Oh, the memories. It would factor to that. And then this would factor some more. Now I hope that you can see that the graphing calculator was a lot faster, right? Plus it didn't have to remember the factoring cubics, which technically is not part of the IB curriculum, but part of the grade 12 curriculum in math. So we could do this by hand because we've done this in our grade 12 curriculum. The rest of the IB world would be scrapped. You have slight advantage at this moment. Slight advantage, although when I asked, do you remember that? I had a bunch of tentative giggles in this class, meaning I don't remember how to do that at all, right? So, slight advantage. All right, I want you to try this one on your own. Some preliminary stuff. Did you get the derivative right? Did you find it correct at 3 to be 6? The derivative will be -1. But if you plug in 3 into your derivative, the -1 is your slope. If you plug 3 into your original equation, you will just find your y-coordinate of your point. And what are the two things you need for an equation of a line? You need a point and your slope. Then once you have your point and your slope, I use the y minus y1 this time. You get -x plus 9. Your slope of your normal will be +1. And you get y equals x plus 3. Try the next one. So, what do we know? We know that if we took this equation of the normal, we would know the slope of the normal. And if we know the slope of the normal, we know the slope of the tangent. And if we know the slope of the tangent, that means if we find the derivative, we know that when x is 1, the slope of the tangent is 8. So that means I can plug in 1 for x, and I can plug in 8 for the derivative. That lets me solve for k, and k is equal to 2.